Hey everybody, it's Mrs. Bianchi. We're looking at questions 5A and it has a part B, 5B, that both deal with the same sculpture. So let's take a look at what they want us to do. An artist plans a sculpture by stacking two cubes. Choose the algebraic expression the artist can use to find the volume of the sculpture. So we have a cube here and we have a cube here on the bottom. So this one, they give us the dimensions. Now, I'm just going to use a different cube and I'm going to just show it to you in the camera. This is, I had a student that took some of these are called cubic centimeters. So I have a bunch of these. I have a whole container of these, as a matter of fact. And you can put them together and you can make different rectangular prisms or even cubes. So I did have a student do that with this one. So you can see that they very carefully tape them together. And in this case, you can see the dimensions are it's 4 across, 4 going, from left to right. It's 4 going up and down, and then it's 4 going deep. So in other words, it's a 4 by 4 by 4. So if I wanted to know how many of these cubes that we needed to make up this thing, then wouldn't I be doing 4 times 4 times 4? So let's apply that thinking to the top cube. So the top cube, we know the dimensions. It's a 3 by 3 by 3. So we have to find what 3 times 3 times 3 is. And let's chunk it up. So 3 times 3 is 9, and 9 times 3 would be 27. All right, so this piece right here is going to be 27 cubic centimeters. All right, but what about this one that we don't know? We don't know. Now, what are we doing to the sides? Isn't this the same thing as whatever the side is, which in this case is 3 to the third power? So if we didn't know it was 3, but it was just some value, then we might use a variable, and they're using the variable x. So for this larger one, we have x to the what power? To the third power, right? And aren't we really adding these two things together? So which one shows the result of this added to this to get the total volume of the sculpture? Wouldn't that be choice B? Because if you look at choice A, what's wrong with that? This is showing x squared. That would only give us like a flat sheet of paper, not a three-dimensional thing. And some of you might be wondering what's wrong with choice C. Because this part's okay, but look at the second part is not okay because this is squared. If this had been x to the third power, then we might look at that one, but it's just not right. So you're going to pick choice B. Now, if you look at the second part, it says find the volume of the sculpture when x is equal to 5. So we're going to take our expression that we chose, which is this one right here, 27 plus x to the third power, and we're going to substitute in the value 5 for x. 27 plus 5 cubed. Now, if you don't know what 5 cubed is, by the way, I happen to have a cube. See, here's one that another student made. And you can see that it's 5 going across, 5 up and down, and it's 5 deep. So it's a 5 by 5 by 5. So if we had to figure out how many of these did my student who constructed this for me use to make this thing, we would have to do 5 cubed. So that means, let's write it over here, 5 cubed means 5 times 5 times 5. Now just 5 times 5 would be 25. We still have to do 25 times 5. Now, if you don't have a calculator, you're not allowed to use one, then just do the algorithm off to the side. Finish this, and that's what you're going to put in this box. Now, when you're done with that, don't forget you have to add 27 to it, and that will give you, you're going to be looking for answer choices here for 5B. If it's a multiple choice, figure out what the sum of those numbers is and choose it. And if it's not multiple choice, then write down what that number is on your piece of paper.